Last section in chapter 5 has to do with writing functions based on their roots or their zeros. Let's say we're given these 3 zeros of a function and we're asked to write the actual equation. If we know the zeros, we know the factors. It would be x plus 2, x minus 3, x minus 7. And from here, we just want to FOIL these guys out. So let's say we started with these ones. Okay, we're going to take this x, distribute it, and then the same thing with that 2. Okay, we get that, which turns into x squared minus x minus 6. Next, we want to take this second parenthesis. I always go the smaller one to the bigger one. FOIL that in. When we do that, we get this huge row of 6 numbers here. And lastly, we want to combine any like terms. So I see like terms here, 2x squareds. I see x's. And we put those together, we get our polynomial. So you can see these are pretty straightforward. There are a few things you need to look out for, with the first being imaginary numbers. Anytime we see an imaginary number, these always come in pairs. So if it gives us a negative 2i as a 0, we automatically have to know that there's also going to be a positive 2i. Okay, it's always because anytime we solved one of these, it was always plus minus 2i. It was never just the positive or just the negative. All right, so that being said, we would write them out as zeros just like the last time. Okay, x minus 2i gives us this factor right here. Sorry, x minus negative 2i switches to a plus, and then x minus 2i gives us that second one. We want to simplify this, and when we do it, we always want to start with the two that have imaginary numbers. We're going to FOIL this out just like we did the last one. First outside, inside, last. Okay, it gives us this. Now when we look at this, these are conjugates, which means these two middle terms are always going to be opposites of each other. We have a negative 2x, negative 2ix, and a positive 2ix. Those are going to cross each other out. Remember also that anytime we see an I squared, we can replace it with a negative 1. Okay, so basically this just switches the sign there and makes it a plus 4. So now we have x minus 6, which is that first factor. And this whole thing turned into an x squared plus 4. And again, we want to FOIL them out. Okay, so now we have x cubed plus 4x minus 6x squared minus 24. I wrote it like this on purpose because when I FOILed it to the 4 here before I FOILed that 6 to the x squared. Make sure when you write it, we want it in descending order by exponents. So we want the 2 to come after that x cubed. We want the x to the first to come after the x squared. All right, 3, 2, 1. Constant is really x to the 0. Similar to the imaginary numbers are square roots. Anytime we solved a quadratic that ended up with a square root in the answer, it never gave us just one of them. It was always plus minus radical 7. Okay, so if it gives us the positive radical 7, we have to know that there's also a negative radical 7 there, even if it didn't write it. Okay, just like last time, we write out the zeros. X minus 2, x minus radical 7, x minus negative radical 7 turns into a plus. And we want to start FOILing. Okay, let's start with these two. Okay, if we start with these two, it's going to make it a lot easier because, again, these are conjugates. And when we multiply conjugates, certain things cancel out. FOIL it out. Okay, we end up with two middle terms, again, that are opposites. Those guys cross out. At the end, we have minus radical 49, and conveniently, radical 49 equals a 7. So that whole thing turns into x squared minus 7. And just like the last time, we want to FOIL this again to get our answer. Okay, make sure it's written in descending order by exponents. X cubed minus 2x squared minus 7x plus 14. Hopefully right now you're thinking this is pretty easy and straightforward. Unfortunately, there are some that are hard, like this one here. We have 2 zeros written out. We have a 4, and then we have 2 minus 3i. Okay, this is another conjugate problem. Anytime we got an answer like this, it would have been 2 plus minus 3i. Okay, those imaginary numbers always come in pairs. So we need to know that there's also a 2 plus 3i here. Now when we write this out, okay, subtract all our zeros, x minus 4, x minus 2 minus 3i, x minus 2 plus 3i. Okay, let's look at just those conjugates at the end there. Let's deal with those to kind of clean it up a bit. All right, first thing I want to do is I want to put all the real parts together and separate out the imaginary part. Okay, so x and 2 are both real, 3i is imaginary. So to do that, I'm going to distribute this negative to the things on the inside. So I have a 1 here, and it's going to distribute, it's going to change that sign in both of them. Okay, it would change this sign. And now we have this. Okay, so I grouped the x minus 2 together because they're both real, and I separated out that 3i. Okay, we still have one that's a positive, one that's a negative. They've just switched where they are, which really doesn't matter. Next up, okay, let's FOIL those two parentheses. So when we FOIL these first ones, x minus 2 times itself, I'm just going to write it as x minus 2 squared. In the middle, just like the last two problems, we have two things that are opposite. Okay, here we have a minus 3 times x minus 2 times I, and then it's followed by the same exact thing with a plus sign, which is great because we can just eliminate those two. At the end, when we multiply those, 3i times 3i is 9i squared. It's a negative because one was a positive, one was a negative. So simplified down at this point, okay, we have this squared, which I can write twice because we're going to have to FOIL it. And then we have the minus 9i squared at the end. Okay, you are probably expecting that we're going to have to FOIL this out. That's going to turn into x squared minus 4x plus 4. And this I squared always is just a negative 1, which switches that to a plus sign. Okay, we have some like terms. Those go together. Right, the whole thing turns into x squared minus 4x plus 13. That's a lot of work to get that x squared minus 4x plus 13. That's why I said this one is a hard one. Okay, at this point, it's right back to what we're used to, which means we're going to take our smaller one, FOIL it into the larger one, okay, and make sure we combine like terms before we get our answer.